Visually speaking, a vector space is a collection of vectors where you can add them together, scale them by numbers, and still they stay in the same space. A vector space is a natural extension of Cartesian coordinate system. For instance, a 2D Cartesian system is like two perpendicular sticks holding up a flat plane. In 3D, it is three mutually perpendicular sticks forming the frame for a 3D space. Vector space come with many important ideas in linear algebra. In this video, we'll look at a few of the most common ones. For instance, a linear combination is just a weighted sum of vectors that all live in the same dimension. Let me give you one example. In RGB color space, every color vector is a linear combination of red, green, and blue vectors. Vectors are linearly independent if none of them can be written as a linear combination of the others. In other words, each vector points in a new direction. No vector can replace another. On the other hand, vectors are linearly dependent if at least one of them can be made from the others. Let's go back to RGB color space to see linear dependence and independence geometrically. Clearly, the set E1, E2, and E1 plus E2 is linearly dependent because E1 plus E2, this vector, is just the sum of E1 and E2. It lies in the same plane spanned by E1 and E2. If you remove any vector from this set, the remaining two become linearly independent. And no matter which vector you remove, the remaining two still span the red-green plane. For example, if you remove yellow vector, the red and green vectors still span the red-green plane. Let's remove the green vector. We'll see red and yellow vector still span the same plane. And if we remove red vector, yellow and green vector, they still hold up the same flat space. Strictly speaking, as we mentioned before, the RGB color space is not a true vector space, but still, it is a really great way for us to build intuition. A basis is a set of linearly independent vectors that span a vector space. Simply put, a basis works like latitude and longitude on a map. Once you have the axes, every point has a unique coordinate. For instance, the red-green vectors can form a basis for the red-green plane. They are clearly linearly independent. Neither can be made from each other. In fact, red and green vectors are perpendicular to each other. The dimension of a vector space is just the number of vectors in its bases. For example, the red-green plane has a dimension of 2 because it takes 2 vectors to span it. Yellow and green vectors can also form a basis for the same red-green plane, but yellow and green are not perpendicular. So we see that a vector space can have many different bases